Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss electric potential energy of a system of point charges. Let's begin. What is electric potential energy of a system of point charges? Electric potential energy of a system of point charges is defined as the amount of work done in bringing the charges constituting the system from infinity to their respective positions. To their respective positions. What it says? Electric potential energy of a system of point charges. Here we take the system of point charges. The coordinate axis x, y, z. There are system of point charges. A charge q1 having the position vector r1, q2 having the position vector r2, q3 having the position vector r3. Let qy having the position vector ri and point charge let qn having the position vector rn. These are the system of point charges. Our aim is to calculate the electric potential energy of a system of point charges. We define that what should be the electric potential energy of that of system of point charges means the amount of work done in bringing the charges from infinity to their respective position. Means I take that charge q1 from infinity to that point having the position r1, and again the charge q2 from infinity to that of position r2. Then what should be the work done is nothing, that is the potential energy, that is the electric potential energy of this system of charges. First I take 2 point charges and calculate the electric potential energy, then prefer 3 point charges and calculate the electric potential energy, and finally by taking that pattern, similarly we calculate the electric potential energy of the system of point charges. Okay. First case 1, taking the system consisting of two charges. Case 1, system consisting of two charges. Then what will be the electric potential energy? Let I take the coordinate plane. X, y, z. Let the charge q1 at the position vector r1, q2 at the position vector r2. Then electric potential energy due to these 2 point charges will be the amount of work done moving that point charge q1 from infinity to that point. Means first we take that charge q1 from infinity to that point r1, then what should be the work done? Then bringing that charge q2 from infinity to that point. So here that system consists of only 2 point charges q1 and q2 with their position vectors r1 and r2 respectively. Let us calculate the electric potential energy of that system of two charges. Here remove the two charges, that is q1 and q2, and place them at infinity. First we remove that and place them at infinity. Now move the charge q1 from infinity. First remove these two as infinity, q1 and q2. First move the charge q1 from infinity to their position vector r1, respective position locations, that is r1 vector. In this case work is done will be 0 because the charge q1 has not been moved against the electrostatic force. Since q1 and q2 are at infinity, there will be no such charge, means there will be no such electrostatic force. So the work done moving the charge q1 from infinity to their respective position r1 vector will be 0 because there will be no such electrostatic force here. So here we write that W1, the work done moving the charge q1 from infinity to its respective position, that is r1 vector, is W1 will be 0. Why? Since q1 has not been moved against the electrostatic force, since there will be no such electrostatic force. electrostatic force, means Q2 charge also is at infinity. Now move the charge Q2 from infinity to their respective position as R2, the position vector, because charge Q2 is moved in the electric field due to the charge Q1. Now the charge Q1 as at the respective position R1, and we move that charge Q2 to infinity to their respective position R2. So here the existence of electrostatic force and that work is done against that of electrostatic force due to the charge Q1. So there will be some work done. So here we write work done in moving charge Q2 from infinity to its respective position against the electrostatic force of charge Q1. Electrostatic force due to the charge Q1, and that work done is written as W12, means work done in moving the charge Q2 from infinity to the respective position, that is R2 be the position vector, against that of electrostatic force of charge Q1, that is given by W12. That is work done will be how much? That is potential at location the position vector R2 due to charge Q1 into Q2. That potential will be how much? Potential at the position vector R2 due to the charge Q1, that is 1 by 4 pi epsilon naught Q1 divided by its position, its distance, that is R2 vector minus R1 vector magnitude into Q2. Therefore W12 is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R2 minus R1 magnitude. That is the work done. So the total electric potential energy of the system of two charges, we just add these two. Therefore total electric potential energy of system of two charges that is U is equal to W1 plus W12, or U is equal to W1 value will be 0, W12 that is 1 by 4 pi epsilon naught Q1 Q2 divided by R2 minus R1 magnitude, or U is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R2 minus R2 R1 magnitude. Take it as equation number 1. Here we calculate the electric potential energy consisting of two charges. Now we take three charges, three charge system, then what should be the electric potential energy? Taking case number 2, case number 2, case 2, system consisting three charges. System consisting three charges. Let we take that of coordinate system. X, Y, Z. The system consists of three charges. Let Q1, Q2, Q3 with their positions vector R1 vector, R2 vector and R3 vector respectively. Now remove these three charges and place them at infinity. At infinity we place these three charges Q1, Q2 and Q3. Now first bring the charge Q1 from infinity to its respective position, that is R1 vector, the location of that of Q1, that is the R1 vector. So there will be no work will be done since there will be no such electrostatic force. So first case W1, here W1 is equal to 0, W1 is equal to 0. What is W1? W1 is the work done due to moving the charge Q1 from infinity to its respective position. Work done will be 0. Why? Since there will be no such existence of electrostatic force. Now bring the charge Q2 from infinity to its respective position. So here the work done will be the effect or electrostatic force of the charge Q1. Now bringing the charge Q2 from infinity to its respective location, that is R2 vector, then the work done will be W12 due to that charge Q1, that is 1 by 4 pi epsilon naught Q1 Q2 divided by R2 vector minus R1 vector magnitude, as we discussed previous case W12. Now bring the charge Q3 from infinity to its respective location R3 vector, and the work done, that is W13, is done due to the charge Q3 in the electrostatic field of charge Q1, and so here Q3 is bring from infinity to that point. So the work done is due to the effect of the charge Q1 and Q2. So here two work done is done, one is W13 and another one is W23. W13, that is the work done in moving the charge q3 from infinity to the respective position in the electrostatic field of charge q1, that is W13, and W23 is due to the electrostatic field of charge q2. These two work done will be done when bringing that of charge q3 to its respective position. So, W13 will be how much? 1 by 4 pi epsilon naught q1 q3 divided by its position vector, that is r3 minus r1 magnitude. Again W23 due to the charge q2, 1 by 4 pi epsilon naught, that is q2 q3 divided by r13 r3 minus r2 magnitude. These are the total work done. We have to calculate the total electric potential energy of the system of 3 point charges. Therefore, total electric potential energy of system of three charges is given by potential energy U is equal to W1 plus W12 plus W13 plus W23. Here W1 0 plus W12 1 by 4 pi epsilon naught q1 q2 divided by r2 minus r1 magnitude plus W13 1 by 4 pi epsilon naught q1 q3 divided by r3 minus r1 magnitude plus 1 by 4 pi epsilon naught q2 q3 divided by r3 minus r2 magnitude. Here we take the common term as we take 1 by 4 pi epsilon naught as common, that is q1 q2 divided by r2 vector minus r1 vector magnitude, that can be written as r12 plus q1 q3 divided by r3 vector minus r1 vector magnitude, that is written as r13 plus q2 q3 divided by, that is r23 r3 minus r2, that is r23. This is the total potential due to these three charges, where we take the position vectors r2 minus r1 magnitude as r12 and r3 minus r1 vector its magnitude r13 and r3 minus r2 magnitude, that is r23. That equation can be written in the summation form as, that is U is equal to half 1 by 4 pi epsilon naught summation over I from 1 to 3 summation over j from 1 to 3 qi qj divided by rij. Here I is not equal to j, that is written in terms of summations. Here we use the factor half is implemented as each term gets counted twice, as each term counted twice. That is why we use the factor half. Here we get the potential due to 2-point charges. This is the potential due to 3-point charges. In the similar pattern, we can observe similarly if the system consists of n charges, that is q1, q2, q3 up to qn at their locations r1, r2, r3 vector, rn vector respectively, as we firstly take that figure here charges, then total electric potential energy of the system consisting of n point charges is given by U is equal to half 1 by 4 pi epsilon naught summation over I from 1 to n summation over j from 1 to n qi qj divided by rij, whereas I is not equal to j. The total electric potential due to the system of point charges. So, with the help of this video lecture, we understand what is the electric potential energy of a system of point charges. These are the system of point charges. First, we take system consisting of 2 charges and we calculate the electric potential energy. Then we take the system consisting of 3 charges and we calculate the electric potential energy due to the system consisting of 3 charges, and taking the similar pattern, finally we take the total electric potential energy as a system consisting of n number of point charges, and that expression is given as in that of bracket. So, with this useful and informative notes, let me wind up this session. Thank you.